Hello and welcome back. This is your lead instructor, Gennaro here, and today we're going to be talking about cryptography basics, brought to you by ACSMI. Let's get started, shall we? The introduction to cryptography, right? It lies at the heart of safeguarding information from unauthorized access to preserving data integrity. Now, whether you're looking to just secure the emails by enabling secure online transactions, when we're talking about email back and forth, like email exchange, or implementing solutions at an enterprise level with cryptography at its core. Basically, what it is the art and science of encoding and decoding information. We talked about it before. Plain text, using now algorithms, keys, and everything like that, and now creating ciphertext. We'll dive more into that on that. Now, I did mention before about the differences between cryptography. You have your symmetric and asymmetric. Symmetric uses one shared key. Asymmetric uses a pair of keys. Okay. Now, one of the other things is understanding that there's a purpose to this, which is all about ensuring confidentiality, integrity, right? Understanding that when we look from the outside in and we're looking at data flowing across the network, if it's in plain text, we can see that. If it's some form of encryption, we can't see that. Some techniques, though, are going to be stream ciphers and block ciphers. The difference is that stream cipher, they're going to encrypt one bit at a time. Whereas a block cipher, this is going to be blocks, fixed sized blocks. An example could be 128 bits at a time, right? Now, it's most secure and very efficient for data that's static, that's not moving, right? That's not dynamic. Versus stream cipher is really good for dynamic data in transit, right? Like live video. When we're talking about AES and all the different aspects of it, AES is considered a block cipher. Symmetric techniques, or AES, right, or understanding the aspect of, well, there are 2 or 3, 4, maybe 5 different ways to look at this. Now, techniques within symmetric AES, for instance, it's a highly, highly sought after secure algorithm and is widely used. And some of the challenges are going to be, how can you distribute the keys and how can you manage the keys within key escrow? I talked about a few times ago around, the similarities of the life cycle, right, of key management, okay, and identity. But ideally, one of the ways to go about understanding and overcoming these challenges is, well, looking at the different techniques of algorithms or going for asymmetric instead of symmetric. Some of the examples of this are going to be RSA, which is going to rely on large prime number keys. Okay, this is really effective for digital signatures. And then if you have like your public key encryption, private key, public key, right? You have your 2 different ones that you're utilizing. ECC and then RSA. Now, if you use RSA and ECC, sometimes what I would look at is, well, how am I utilizing this? A lot of times you'll see it as, well, we're securing that data in transit. Asymmetric is really great for your HTTPS connections, right? The SSL TLS between the browser and the web server, because you're sending and receiving that key, right? The public key to say, hey, I am the server. Here you go, my key, right? And then you're creating a shared connection, an encrypted connection. Now, let's talk about the cryptographic hashing. We talked about hashing being one function. So it's kind of similar to what we're talking about here. Now, properties of a secure hash. The same hash always produces the same output. Oh, that makes sense in a way. It's not reversible, like I just talked about, one-way function. And ideally, it's collision resistant because no 2 inputs can produce the same output hash. Algorithms that you can utilize are going to be SHA-256 is one of them, which is widely adopted, widely used. And, well, MD5, you don't want to necessarily use that anymore. It's not so much secure now. A lot of people don't want to use that. More so for higher SHA, and there are more that have been coming out as well too. But ideally, just think about the aspect of what it means to have secure hashing techniques. Because you can create a hash from a file. I talked about before where that's all about the integrity of the data itself, right? Because if you were to make any changes to that file after it's been hashed and you try to run SHA-256 again, it's going to be a completely different hash. It absolutely should be. If it is not, that's a collision there, and that's a problem. Let's talk about digital signatures and authentication. Well, we know that a digital signature validates the authenticity of a person. It's basically saying, hey, I am user, and I'm using my private key to sign a document, because that's talking about non-repudiation, right? And then if the hash itself of the document that was attached to that email matches the original, then authenticity is verified. So a use case could be you were wanting to secure software updates, right? Now, we know that this actual package goes on the internet, goes on our server, and it can be downloaded. Well, you can create a hash around that, right? Because, well, we'll know if the actual package has been tampered with. That's that data integrity. So you want to look at advanced techniques of how you can combine the use of signatures with PKI for identity validation. We talked about public and private key. Everyone will know and can know your public key, but everyone should not know your private key. So PKI, public key infrastructure, this is that 2 keys that we're talking about, is going to utilize X509, where you can digitally sign documents that are linked to the public key within that user. That's how we know that person is who they say they are. And then you're utilizing CAs. Now, you've probably seen this within your browser. You have a padlock, you can right click on it, you can dive down into it and see the different certificates. And then when it comes to the key revocation of it, as in you're revoking keys, this is all about certificates that are not valid anymore, right? When they're compromised. You want to be able to revoke that key. You sometimes may see, as you're browsing the internet, self-signed certificates. You may want to kind of stay away from that too, but it really just depends on, on who that user is. But it could be just something that they have not set up on their own yet. Or it could be impersonation. It could be someone saying, hey, I am google.com, but I'm not really, because look at my certificate. I self-signed it. It was not given to me by CA. Now, some examples of this, right? You can secure cloud services through the use of encryption. I highly recommend that, of course. So the example here, at least the situation, is an organization, right? They are storing sensitive financial data on the cloud platform. Now, breaches or unauthorized access could still compromise the data, but what can you do? Well, you can encrypt the data before uploading it to the cloud, right? You can use ACSMI, that symmetric algorithm that we talked about, where it's going to give a very quick way of encrypting that data, right? Quick way. Now, the outcome is, even if a breach occurs in the cloud and, it's third party, maybe they're not securing the data like they're supposed to, or securing their systems. Now, I don't want to say data, but securing their systems like they're supposed to. Well, if that data gets compromised, it's still going to be unreadable. That's a way you can have a favorable outcome in ensuring the confidentiality, right? Because we're talking about the unauthorized access of the system, of the data itself. But it's been great. It's Gennaro here, CEO of Cortex Solutions, your lead instructor. And we just talked about cryptography basics, brought to you by ACSMI. Take care. Look forward to seeing you in the next one.